All right, hello, welcome. We are finally getting on track here. This is the first of our distance learning lecture recordings. Today we're going to dive into the third iteration of our programming proper JavaScript lectures. But first, it's been a minute, especially given the rockiness of this middle of semester change up. So let's have a little bit of a recap on our JavaScript so far. We've touched on a lot of important things. We've gotten the basics of sequencing operations and how certain things will execute on the page. We've also gotten into how to assign variables and access them and use them for things, right? How to store information in a spot that your script has access to, right? We've discussed how to define functions and how to use existing functions. So, these more complex, reusable chunks of code that are more clean and more useful than just strictly writing everything top to bottom, right? A lot of what we're learning as a common thread is how to fold in common work to be reusable in multiple situations, and that's especially going to happen today. So we also talked about branching logic. That was the most recent lab. How we can make our code branch based on certain conditions, right? If it's raining outside, I will grab my umbrella. If it's not, I will not, right? And then finally, also we've talked about we've dealt with how to deal with objects from the document, especially element objects from HTML. We won't dive into creating our own objects here just yet, but that's still on the horizon. It's a useful topic. So let's do a quick visual recap. So here's the key. We have unassigned variables, variables that contain primitives, variables that contain objects, some function names, and then just actual primitives. So let's look at a paragraph element, right? Paragraph object. This is just the top part. Ignore, more or less. It's just a label, right? What's actually inside that paragraph object? It has an ID value, right? It's a variable. It has a variable of its own called ID, and that contains stuff. In this case, it has some kind of text content, inner HTML. Nothing in it today. And it has a style object with its own variable. For instance, color. The color black. And we're not displaying this paragraph, but just imagine it, right? It's a blank paragraph that it's black and it has the ID stuff. So let's do a quick script to do something to it, right? Open our script. We define a variable page text. There's nothing in it. Then we assign that empty variable something. To do that, we go to the document object, which is always exists, and we we use its function, its method, get element by ID. In this case, stuff is the ID we're looking for. And then now page text has an object in it, right? It has a reference to this paragraph object. So we want to change its inner HTML variable to bunch of stuff. So now that leads us to, from the start, the page shows nothing, in quotes. And then after our script executes, the page says bunch of stuff. Neat. Okay. Now let's recap branching. Similar scenario. Let's open a script. Variable, this is our condition. I have cat facts. In this case, it's true. Variable page text is still empty. We're going to give it the same thing. Go grab this object from the document. Now we're going to have a branch. If I have cat facts, this is true or false, right? If it's true, page text we're going to change to cat facts, and otherwise no cat facts, frown, right? Let's see what it looks like real quick. Page shows nothing. I have cat facts. Is it true or false? If it's true, page will now show cat facts. If it's false, page now shows no cat facts, frown. So that takes us up to the current moment. So far, we've talked about all these basic abilities. They've given us some interesting power. We can kind of change everything on the page at our whim. We can respond to user input. We can call our own functions when the user hits buttons and stuff like that. That's pretty cool. Clicks things, etc. And we can also respond to different contexts. We can have our script do different things based on the current context, right? If the world is this way, do this. If this item contains this thing, do this, right? Something what we haven't talked about so far, though, is repetition. This is one of the most powerful things that a computer can do because we aren't good at it. We like to do things once, and then it's kind of annoying after that, right? So the processor your processor and every computer, including your phone at this point, can do billions of operations per second. I say mathematical here, I mean, that's everything, right? Even processing a string is just moving math around inside of a computer. So it can do billions of these things. But we're not going to be writing a script to take advantage of doing a billion lines of code. That's way too big, right? And as we've already seen, we're already interested in reducing things by putting them into functions, putting them into variables, that kind of stuff. What we're going to get into, though, is loops. Loops are what give us the ability to really knock it out, really put the processor into high gear to be able to do a lot of work for us at once. Now, our examples, we aren't going to be, especially in this class, we won't be really taxing the processor to the maximum, but I'll show you an example next time in the demos of something that does just that. So loops. How do we conceive of a loop? What is a loop? Loops tell the program to double back and do the same code over and over until a certain condition has been met. Or more accurately in how we define them, until a condition is no longer met. But in this case, we're going to use this hammer example quite a bit. I hammer the nail over and over, knock, 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 bang, 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 until, right, this is the key, it's flush with the wall. I don't keep going, and I don't stop before that. I loop my behavior until the nail is in. So let's talk about loop structure in general. First, you have to initialize, like, what am I going to be monitoring here? What am I going to be doing? Then I have the instructions that I'm going to repeat. So for the initialization, it's like setting the nail up, right? This is the thing I'm going to be paying attention to decide how long I should repeat my behavior. Then I have the behavior to repeat, my hammering, and this also includes sort of an update that changes the variable, changes the height of the nail, right? As I keep knocking it, pounding it, until a certain condition is no longer met. So as long as the nail is not fully into the wall, I am going to keep pounding it. So a quick little example here is we can set a variable not done is true, while not done, right? While not done is true. Right? Do stuff and then update not done. We may decide that we're done at some point, right? So as long as that condition evaluates to true, the program is going to loop over the instructions. So let's do this with the same example of hammering a nail. Again, we're going to keep using this. And this is the sort of the common sense looping. Initialization. The nail's height is set to 2 inches. Okay. Instruction is pound the nail, right? Do some function, this physical function of move my arm to pound the nail. We get an update for free out of this because we change the nail's height. We make it shorter. The distance of its head from the wall. That's what I'm calling the height. We repeat this over and over. Pound, check the height. Pound, check the height until, or we're allowed to do this as long as the nail's height isn't 0 inches, right? Once it's 0, we stop and then we move on to have dinner or whatever, right? So loops in JavaScript specifically, how do we conceive of this? We're trying to get down into code. So there are two primary kinds of loops, and you'll see these in virtually every language, but there's two kinds of loops. While loops, these are the most basic and most flexible, and then for loops are a little more convenient syntax. More or less, these things are interchangeable. You can achieve the same things with both of them, but I think for loops have a little bit more ease of use, and while loops are a little more like you can get a little more custom with how you handle them. So while loops, we'll start with these. While loops are pretty straightforward. Do the code in the curly braces over and over until the condition evaluates to false. This is just like what we just did with the hammer. So we also need to update the condition during that code execution somehow, so that we decide when we're done. And it requires a little bit of setup. You have to define some kind of variable to keep track of before you start the loop. And then you do stuff over and over. You repeat doing things, etc. And then you update the condition of, hey, are we done yet? Right? Based on what's happening inside the loop. So let's hammer something into the wall using a while loop. So first we got to set the nail height. In this case, I'm just setting it arbitrarily to the value 10. We'll assume it's in centimeters or something. That's still pretty long, but either way. So while nail height is not 0, right? As long as it's not flush with the wall, I'm going to log to the console, bang, something is banging, making the sound bang. But I'm also going to update nail height. I'm gonna make nail height equal to nail height minus 1. Cool. So let's follow this. What happens? How many loops occur? So at the start, nail height is 10. Cool, 10. And then we bang. It goes down by 1. Bang. It goes down by 1. We're still not at 0. Bang. Bang, 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 bang. All right, we've reached the point at which the while loop can no longer loop because it says, aha, nail height is equal to 0. This is not accurate anymore. I'm only allowed to loop when it's not 0. So I exit. Great. Cool. We hammered this nail into the wall in 10 strikes. We can change that. What if we go faster, right? And we update this to be nail height minus 2. Ooh, interesting. Okay, so bang, 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 bang. Oh, great, we did it in 5 steps. You know, we're getting better at hammering. That's good. We're not as tepid about it. Cool. So I think I'm hoping we're seeing how this updates, right? Nail height changes. We bang several times. You know, we create these banging situations in the console, and then we have nailed the hammer's height into the wall, or the nail's height into the wall. So let's go faster. Let's make it 3 at a time instead. Now how many loops are we going to go? Hey, all right, we start with 10. Bang, it's down to 7. Bang, it's down to 4. Bang, it's down to 1. Bang, it's down to -2. Now wait, nail height is not equal to 0. That's still true. -2 is not equal to 0. Uh-oh. -5, bang. -8, bang. Oh dear. All right. I'm not getting my deposit back after this. So this should illustrate the concept of infinite loops. This is something to look out for. It's very easy to design a loop such that your condition never becomes false. And then what happens, so in the hammer example, we were updating by too much and we skipped right over the 0 condition. Oopsie. So the program just executes that same code forever. In this case, the hammer robot will destroy my wall and probably fall outside. I don't know, depending on which wall it's hammering. So in this case, I mean, you have to kill the process. In JavaScript world, you try to close the page. It might lag a lot while you're doing that. And in the worst case, when you're doing this in different kinds of programming languages, you might have to shut down the whole computer. So infinite loops are something you really want to avoid. It's easy to make it happen by mistake. You don't want to linger on it. So just keep them in mind. If you run your program and it just freezes, odds are pretty good you've entered an infinite loop. In fact, a lot of problems that are happening in your everyday computer life, sometimes it's due to infinite looping scenarios. So how do we fix it? How do we fix this to be better? Well, we can change the condition to be as long as nail height is greater than or equal to 0. This sets it up so it's not pinpointed directly on 0 as the destination, but it's making 0 the upper bound of the point at which we should stop, right? So let's do the logic one at a time. So now 0 and all negative numbers should trigger the end condition here. So 10, bang, go down to 7, bang, go down to 4, bang, go down to 1. So 1 is still greater than or equal to 0. Good. Negative 2 is not greater than or equal to 0. Aha. Okay, cool. We have excluded negative 2 and all other negative numbers, so now we will not be banging anymore. Although, we might have still, we knocked it 2 units of distance deeper than it needed to be. So maybe still don't hammer at 3, at a rate of 3. So, okay. I hope this has made sense so far. The way that we can use loops to change variables repeatedly, that kind of thing, right? So back to while loops in general, these are the most basic looping structure. They're powerful. I mean, they're as powerful as a for loop. This is the way in, the entry level to creating programs that can do a whole lot of work. Loops is where we get the real work done. But keep track. It's especially easy in this scenario to make infinite loops because you might have forgotten an update somewhere. You may have failed to define your condition properly, that kind of stuff. So you have a little bit more power and control. Well, maybe not power, but while loops, you have more control over what you're doing with them and also, therefore, more responsibility. So before we move on, there was a bit in this that we've been working with that can cause a little bit of confusion. So remember, we're working with variables, right? So what are the things we can do with a variable? We can read it, see what's inside of it, and we can assign a new value to it, right? And so when you update a value inside a variable, you have to do both at once. So let's do that real quick. The most simple way to update a thing is, say, x is our variable, right? Whatever it has in it, let's say it has 5. If I say x equals x plus 1, x will become 6, but here's why. So first thing that happens is we read x's current value on the right side here, and then we add 1 to that value, right? So if we see 5, we add 1 to it, and then we're going to assign the sum total back into x, and that all happens in this one line. Now that's straightforward, but it causes some hitching. It's kind of a weird way to think about a single line, right? So this is saying I want x to have the value of its old value plus 1, right? So this line will increase x by 1. Anytime it's called, it will go up, right? So this is useful. The way we've been looking at how to update our loops, we change the hammer's, the nail's height, right? But there's some nicer ways to write this, thankfully, in JavaScript world, and in a lot of languages, but specifically JavaScript. There's 2 super useful shorthands for this. There is the plus plus minus minus notation, which says, hey, if I have a variable x and I want it to go up by exactly 1, x plus plus. That's a full statement. It essentially does what we did on the last page. It says I will add 1 to the value inside of x. Works just fine. It's clear, it's simple, and it shows exactly, most people know what this means, right? Now, if you want to get more custom than just plus exactly 1, you can do x plus equals. which will increase the value by whatever you put on the other side, right? You could have it increase by a certain amount based on the result of a function. You could have it increase by a random amount if you call it a random function, that kind of thing. So, yeah, there's these two different ways of shorthand updating the variable x, or any variable. Very useful. So, now that we've cleared that up, let's look at another kind of loop available to us in JavaScript, for loops. So, for loops are similar to while loops. They're more convenient because they put everything in one place. It rolls that whole setup condition update idea into the the declaration of the loop. Oops, sorry, hang on. That's how you know it's live. So for instance, here's an example, but let's pull it apart on the next page here. So when I define a for loop, I put the setup function, or not function, but the setup statement first. So this is what happens before the loop even begins. And typically what you're doing in there is you're defining a temporary variable that is only usable during the loop. It doesn't collide with other variables. It's a temporary variable that is used just for the duration of the loop. And then you have a condition, just like in a while loop. It says, hey, as long as this condition is true, I will continue to execute the loop. Otherwise, I will stop, right? And then we have the update. And this will happen at the end of the loop before the next loop. And this is typically where you put your variable plus, right? We'll see some examples again here. So a note here is that technically setup and update are optional. You don't have to have both or either of them. But if you don't have either of them, you're literally just using a while loop. So you might as well not clutter up your code if you don't want to have the setup and update right there. What this means is that for a lot of simple cases, your setup and your update are going to be short. You're going to define a variable, and then you're going to update that variable. So for loops are great for cases where you're not doing a whole lot of complex stuff in your setup and update. Let's look at how we can apply this to our hammering problem. Well, I'll fix that later. So let's see. First, we define, it's the same problem, right? But we're going to do it all at once, more or less. So what is it? Nail height starts at 10. That's our setup. Nail height, as long as it's greater than or equal to 0, we will continue to loop. And our update happens right in here. Nail height minus. We subtract 1 from nail height, right? And we also, of course, we still have to make the bang sound. So that's it, actually. And now my little spoiler here, the much more succinct, right? This is a shorter way to define the same kind of looping behavior that is a little more straightforward, right? Now the code inside of the loop is just the things you want to repeat and not like the meta information before and after. So it's just good. It's good for convenience. So these are the kinds of things that you will see most often. For loops are the most common kind of loop because they're easy to use and they're clear to read, right? But again, while loops are still useful. So just understand that they both exist. They just have slightly different syntax, but they're doing the same thing. They're saying, repeat this until. Hammer the thing into the wall until, right? I typically prefer for loops just because it's easier for me and everyone to read them, but it's all good. So that's a load about basic loops. You can kind of interchangeably use for and while. They have a little different flavor, but that's fine. And they both let you rapidly repeat a set of instructions that you want to execute a lot, right? That's quite useful in some cases. We'll show a little more about that soon. So it helps you do repeated actions. It helps you compute complicated things, like if you have to do a lot of math over a wide array of items. And it also lets you work on multiple values at once, so say grouped objects. And let me talk about what that means. As the title suggests, we're going to get into arrays. So, yeah, this is plenty about loops. Now let's talk about arrays. Arrays, well, first, a lot of the time we're working with a lot of values, right? We're not just working with a single variable. The DOM is full of objects with variables and properties and all kinds of information in them, right? And there's tons, you may have tons of paragraph objects. You may have tons of things on your page. So far, we've seen how to deal with individual variables, things that contain a single value. So like strings, booleans, numbers, those primitive values. We've also seen how to store a single complex element object. For example, like grabbing the content div and then changing its CSS values, right? So in both of those cases, though, we're looking at variables as containing a singular thing as opposed to containing a set of things. So what happens if we want to deal with a set of things? Here's a silly little example. Let's say I forgot my wallet at dinner and drinks with 5 of my friends. They decided to cover it, and they also happened to split it all evenly, and we all more or less spent the same amount. So ultimately, I owe them each $5, right? And I want to write a script to tell my PayPal to give them all money, whatever. With individual variables, I'm going to have to define each friend and then pay each of them separately. I'm going to have to write a line of code for each of my friends and then pay them with a line of code each. Friend 1 is Anisha, friend 2 is Billy, friend 3 is Catherine, friend 4 is Dan, friend 5 is Erica. And then I pay Anisha, pay Billy, pay Catherine, pay blah, 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 blah. And the fact that I'm saying blah, blah, blah tells you that this seems frivolous. We should be able to loop this, right? Which we'll get into. But first we need to understand how arrays work to be able to make them jibe with looping. So, you see, it was tedious. We had to repeatedly and specifically call pay for each and every friend in our code, like in our written code. That's okay for 5 friends, but what if I have 150,000 employees and I'm changing, salaries or something, doing a yearly update? That's not a great structure. I don't want to have a line of, what if I screw up one of these, or what if I screw up the logic and I have to rewrite all 150,000 lines, right? What we want is a better way to store this kind of information so that we can work with it more consistently. So that's where we introduce arrays. Arrays are a simple way of keeping multiple things in a single variable. So here's an array with 3 items in it. Item 0, item 1, item 2. I start with 0 for a specific reason we'll talk about. Another note here is that just like all of JavaScript, arrays are not strongly typed. You can use whatever you want in each slot. You can mix and match whatever you want. Again, that can lead to some issues. Be careful. But it's also nice to have that flexibility. Sometimes you just want to store a few things together in one spot, right? My friend has a name and they have a wallet amount that I can change, right? Whatever. But really what it's useful for is not holding information about one unit, so one friend's information of variety, but it's useful for holding lots of units of the same kind. For instance, here we have X has three numbers in it, Y has 3 strings in it, and then Z has a string, a number, and a reference to content in the page, right, in the HTML page. Okay, so I hope that makes sense. You're storing one variable name has a bunch of values associated with it. Now the question is, how do we work with that? So, to access array items, with a normal variable you would just call its name, right? If I say var x is 10, and then I say y equals x plus 5, x in that second statement, I've changed, I've x, we know it has 10 in it, so y equals 15. We've called x to get its value out. With an array, you do it a little differently. You access individual items of the array using indexes. So, and this is a note that you'll have to keep track of. The first item of the array is at index 0. Yeah, it's a little counterintuitive. 0 is the first thing in the array. Just remember, all numerals start with 0, and then 1, and then 2. So kind of kick yourself out of the idea that the item 1 will be at index 1. Index 0 holds the first item. Index 1 holds the second item. Again, I know it's counterintuitive. Some of you will be like, why the hell? But it's useful and it's important for a lot of like subtle, weird, computery reasons. Just roll with it for now. And be aware of off by 1 errors. You will make some of those. I still make them to this day. So, okay. In this case, we've defined an array in X. Var X equals 1, 5, and 10. And then var Y, we're going to say, in the same pattern as the above, we're saying, well, I want the third item of X, which is 10, plus 5. Right? So I'm accessing the third item of X, the tooth item of X, second tooth, whatever, the nth. X sub 2 holds 10, and then we add 5 to that. So Y still is 15 at the end of the day. So let's look at a more coded example. Remember, you're working with, so if I just call, so here's X equals 10, 20, 30, 40, 50. If I just call X, when I speak this out loud, I say sub, as in like the sub item. So X sub 0 returns that first item, 10. X sub 1 returns that second item, 20. X sub 2 returns 30, and so on. Neat. So we're seeing that we can access these variables pretty easily. We can also assign information to these variables in very much the same way. You can just kind of treat X sub 0, for instance, as a variable, as you would any other variable in JavaScript. So just like with normal variables, you can put whatever you want in there. And again, JavaScript is very accommodating. It allows you can assign values outside the current size of the array. In a lot of languages, if you try to say, let's say on this previous example, I wanted to put something in slot 50. In a lot of languages, it would say, what are you doing? You're not allowed to do that. But in JavaScript, it says, fine, I'll just put a 50th slot, and there will be a bunch of empty ones in between. So it's a little weird. It's very accommodating, and it can really lead you into some weird errors if you're not careful. So keep track. But it's still useful. It's also quite nice that you don't have to do a whole lot of setup. You can just start assigning variable entry points. So let's look at it again. So I want to change this array. 10, 20, 30, 40, 50, right? I'm going to change each item. I'm going to put in the first slot, I'm going to put 50 at X sub 0. X sub 1, I'm going to put ABBA. X sub 2, I'm going to put false. And then X sub 7, I'm going to put way out. What does that return? When I call X to see what's inside of it, it has 50, ABBA, false, 40, 50, 2 empties, which are interesting little, that's a JavaScript thing that's basically like null. There's nothing assigned here. Don't tread here, right? And then at point 7, wait, 1, 2, 3, 4, 5, 6, 7, yes, way out, which is the final thing I assigned there at slot 7. It just automatically made the array bigger and threw the value right in there. Again, I can imagine some of you lighting up, ooh, I could use that, but also keep vigilant. That's also a way that way lies some madness too. So just be careful with how you use the assigning variables way out. A couple other methods and values. Arrays have these complex, I mean, arrays are complex objects, right? And they have a variety of methods and values you can access that help. We'll talk about a couple of them here, and we won't necessarily use all of these, but it's just good to know how they work. So, x.length is super useful. This helps you decide, especially say if you're going to do some looping, it can decide when you're at the end of a list, right? Join, x.join, it can take a string, so it returns a string version of your array, but it's separated by the string. So say you wanted to separate them all by commas, you can do that. You just pass a string comma in there, and it will return a joined string of whatever was inside. That can be useful, especially when you start to write things onto pages, onto HTML, and when you edit the inner HTML of an object, you might want to have some, carriage returns, that kind of stuff. So, you can custom dump a string version of your array immediately. Then there's push and pop. Now these are a little complex. These are a little bit data structuresy, but they are really useful. So push allows you to just say, hey, whatever's on the array right now, put a new item onto the end of it. So we'll look at an example in a moment. The reverse of that is pop, which will delete the last item, but it also will return it, so you can use it. This is good for building what's known as a stack. Things that you put onto the stack, you have to pop them off before you can get back to the bottom. So, also consider, just looking into, especially on the W3 School site, look into sorting and shifting. These are useful things you can do with arrays. You can dump a bunch of information into an array and then sort it top to bottom if you want. Very useful stuff. So, this is the same ideas, but let's look at them in practice. So, X is, again, an array with 10, 20, 30, 40, 50. Cool. And what's its length? Its length is 5, right? There are 5 things in there. This is useful for, say, doing a less than condition if you're iterating through a list. Join. So if I join this array with the dot string, period, we get 10, 20, 30, 40, 50 with dots between them. Good. Cool. Push 60. Well, I put it in quotes there. I didn't mean to, but it doesn't return anything, but now X contains on the end of it 60. Cool. Pop, on the other hand, when you call pop, it pulls that 60 off, but it also deletes it from the list, from the array. So, great. These are just a handful of functions, right? So what is this doing for us again? Arrays are a useful set of tools to allow us to work with groups of items. And so instead of accessing them by name one at a time, we can access them numerically, which, thinking back, that sets us in a prime position to work arrays and loops together. So these things go hand in hand. It's great. Let's try to pay back my friends, right? Using arrays this time. So, first, what we want to do is define an array of my friends' names, right? We're going to use these names to go and, quote, get my friends using the get friends function that, whatever, doesn't exist. But it's what we're using in the example. So, friends is just an array of Anisha, Billy, Catherine, Dan, Erica. Great. All this related information now fits under the one header, friends. That's quite useful, because now we can reuse references to this single variable, but access different information each time. So now I'll just go and pay back each one of them in a loop. Let's do a loop. Let's do a for loop. So quickly, let's look at the for loop notation again, right? We're going to set up some variable I. I is used often in for loops because you iterate over in a for loop. It often is used as the index, right? We're going to use it right like that right now. So I is a common term to be using as in your for loops for your iterated variable. So I starts at 0 because, again, 0 is the first item of any array, so we want to start from 0, right? As long as I is less than the length of the friends list, right? Friends.length, great. Like that should be 5. And then after each loop, make I bigger. So now, again, this gives us that mathematical way to access each of these variable contents. So let's get into it again. Now remember, the way I've constructed this example, we still have to go and get our friend. So we're going to hold in the frnd variable real quick. We're going to get friend, but we're going to get the friend based on the current I value. So we're going to go to the friends variable, and we're going to get the ith value out. Right now, I is 0. So the first time around, we'll get Anisha, right? Then I'm going to pay Anisha $5. And then I'll loop. Next time around, I becomes 1, so that takes us to Billy, and so on. So as the loop keeps going, I increases, and then since we're using that variable to access our array, that means we get to change which part of the array we're looking at each loop. Again, I hope we're seeing that this is the power here. You can write the same code to do much more complex things. So let's look quick at the iterations. So on the first iteration, I is 0, and the friend we find is Anisha. On the second one, it's Billy. Third one, it's Catherine. Fourth one is Dan. Fifth one is Erica. And we pay them all the $5 we owe them. Ta-da. Fantastic. So, I hope you're seeing now how you can combine loops and arrays to really cool, powerful stuff. But there is one final note here. This is pretty much the best way to loop over arrays. It's a very simple way of handling it. So let's look at for of loops. It's basically just a shorthand. It's a way of looping over arrays in JavaScript. You might see this known as a for each in other languages. Either way, it's the same concept. The idea is for each item of the items in this array, do the code, right? But the cool part is that the variable that you define in this notation is usable during each loop. So, for example, here we have an array 1, 2, 3, 4, 5 for item of X. Do stuff, and we can use that item at any time. So on the first loop, it'll have 1 in it. On the second loop, it'll have 2, and so on. So let's go look at one of the things we've already poked at and do an example. So in this case, X equals 10, 20, 30, 40, 50. We've seen this before. Now we're going to do a little for loop. I wanted to say for thing of X, I'm going to log thing divided by 10. So the loop starts by creating a variable named thing, right? There's nothing in it at the very start when the loop is just getting going. And then during each loop, the first thing that happens is thing is assigned the value of the first item of X on the first loop. And then on the second loop, it'll get the second value. On the third loop, it'll get the third value, and so on. This is super useful because now it's taken out all the issues of, hey, let me rearrange a bunch of indexing to grab the values out of this this array, and instead it just makes them presently available in this variable. It's very conceptually easy. It makes it a lot more straightforward to deal with a list of items. So now let's look at how this executes. So the first thing it will, on the first run, thing will contain 10. I'm going to divide that by 10 and then print that to the log. So the console pops out and we get 1. Cool. Second time it'll contain 20. Divide that by 10. 2, 3, 4, 5. There's nothing left in the list. The loop exits. So once again, this simplifies the process. You know, that's a lot of the beautiful stuff in programming languages. Is it's all about simplifying and making it a little bit more human readable, human editable. So let's pay our friends back with a for of loop. Once again, we're going to define an array of our friends' names, but this time the for of loop is a lot shorter. Remember, we're going to grab out the string value from the friends list there, and we're going to dump it into this little variable f. So for f of friends, I still have to define that variable to grab the friend, but now it's shorter. I make the variable friend, or friend, right, friend, and then I get friend f, and then I pay friend back. So instead of updating a numerical iterator, I now just have the actual value, just easily accessible. Pulls out the names from the loop, or from the array, each loop, and then I can use them immediately. No accessing and futzing around with the indexing and arrays here. Still, this is extremely useful, but it's also very important to know how normal for loops work, because you can't do everything with this. This is explicitly for just using each item in a list. You can't actually assign new values to f. It doesn't do anything. It just changes f. It doesn't change the actual original array. So yeah, overall, this is a powerful tool. Makes it very easy to deal with arrays, kind of any size, right? You can just say, hey, do the same thing on each item in this array. That's pretty cool. So that covers it for arrays and loops. We've sort of kicked up our abilities another notch, right? We've talked about making branching code and basic code, and now we've made very, very repeatable code. We can do the same thing 10 times or 1,000,000 times, and hopefully not infinite times. And we can interact with groups of related objects. That's really useful. And now we have methods combining both to really expand our abilities, our programming abilities. So next, I'll do the demo showing how to apply some of this in HTML and CSS world with JavaScript. And yeah, look forward to that. Take care.